Alright, so then the same rules that we just applied to the vectors in the bracket form applies to vectors in linear combination form. So this is an example like we started with the ones in the bracket form, is we're starting not at 0. So we have an initial point of 2, 6, and then another point of 8, 3. And we want to put this into standard form, which means I need to know what the horizontal component and the vertical component are. So I need to look for those changes. So the horizontal component would be looking at what the change in x is. The change in x to go from the initial to the terminal, we'll do terminal minus initial, and the horizontal component would be 6. The vertical component, I'm looking for the change in y, which would be 3 minus 6, which is negative 3. So in linear combination form, I would write it as 6i minus 3j. And then if you look at the next example, this is just asking you to do the vector operations on it when it's an ij form. So to do this, you're just going to plug the two vectors in. It's 5 times u, so 5 times 2i minus 3j, and then minus 2 times negative 4i plus 2j. You can really just think of these as like terms. The i's are going to go together because they're the horizontal parts. The j's are going to go together because they're the vertical parts. And we're going to start by distributing. So this really is just like an algebra 1 problem. So I'm distributing there and there. 10i minus 15j. And then it's going to be plus 8i. We're distributing negative 2, so it'll be minus 4j. And then we'll just combine the like parts. The I parts get combined together. We get 18i. And the j parts, the vertical parts, get combined together. And we get negative 19j. Hopefully this math should be really, really easy. Alright, the last thing we're looking at is really what that understanding of what a vector is, that it's a quantity that isn't just one number by itself, but it's two things together. It's a magnitude and a direction. So far we've talked about how to find the magnitude. Now I want to focus in on the direction. The direction we're going to find as an angle, and we're going to find it using the triangle and using trig. So these are the steps I go through. If you look in the book, they give you formulas to memorize. I'm not one about memorizing formulas. I like to look at it and see what the math looks like. These are very geometrical, so if you draw them, it will show you what you're supposed to do. So we're going to start by graphing the vector in the correct quadrant. So if I look at this one is in the horizontal and vertical component form. So it says horizontally I'm supposed to go 6, and then vertically I'm going to go negative 6. And you can really just sketch it. You don't have to do accurate tick marks here. But this is my vector right now. So this is over 6 down negative 6. I'm going to put those as the sides. And we want to find, I've drawn in the triangle already because I drew the components, but the triangle should always be with the x-axis. We want to find the direction, which means we want to find the angle, which is theta here. So we're going to use trig to find that. This is the opposite side. This is the adjacent side. So I can use tangent. So it's going to be tangent of theta is equal to negative 6 over 6. We get tangent theta equals negative 1. And since this one is actually a value that we know, I know theta is negative 1 at 45 degrees, we would know that the reference angle in the picture is 45 degrees. Then we would actually have to figure out what the angle would be based on the quadrant that it's in. That's your last step here, is if you look at here, we want to find the direction angle based on its quadrant position. So 45 degrees isn't an angle in the fourth quadrant. We would need to use that 45 degrees and figure out what it would be in the fourth quadrant. So we got to do the math here that this would end at 360. So it's going to be 360 minus 45, which would give us a reference angle of 315 degrees. And again, for this one, you could use your plate to figure that out as well. The next one won't be as easy because it's not going to be something off the plate. So if you want to pause and you want to try number 2 on your own, this would be a good one to stop and try because these are getting a little bit more complicated. And then I'm going to go ahead and fill it in 3, 2, 1. So the first thing I would do is graph it. So this tells me that we're going to go, the horizontal component is -5, and the vertical component is -12. So our vector is right here, and we're trying to find the direction, which is theta. The direction is the angle, so we're trying to find the angle. And right now, again, I'm going to be able to use tangent because this is opposite, this is adjacent. So we get tangent of theta is equal to -12 over -5, which is not on the plate. 12/5 is not on the plate. So now you have to use your calculator. And we're going to give them in degrees. So if you make sure your calculator is in degree mode and type in, we're going to do arctan of, that's really +12/5. And we'll figure out what theta is. That is only going to give you the theta if it were in the first quadrant. We need to figure out what it's going to be when it's in the second quadrant, or third quadrant. Whoops. If you type that in your calculator, you should get 67.38 degrees. So that's what I'm going to put in the picture as that angle. That's 67.38. But now we have to find it if we were to start at the positive x-axis and get to that same stopping point. So if you look at that, that is going to be up to the second quadrant line. That's 180 plus 67.38 degrees more. So we have to do 180 degrees plus 67.38, which gives us 247.38 degrees. That would be the direction of that. And notice that angle now is in the third quadrant, which is what we wanted. We have to report an angle that's in the third quadrant. Alright, one more page. This is just the reverse of what we did on the other pages. They want to find the component form of the vector if we know its magnitude and its direction. So we're going to again start by graphing. For me, these are all visual. Once you get the visual, it's really easy to understand what your next step is. So I'm going to go ahead and I'm going to graph this. First, graph the vector based on the angle that you have to get in the correct quadrant. So I know 50 degrees is right here. And then we're going to make a triangle. And you have to think about where that magnitude is really supposed to go. The magnitude, remember, is the length of the vector. And the vector we're looking at is that first line we drew in, which is this one here. So it's always going to go on the hypotenuse. So if we want to put this in component form, that means we need to know the two components. We need to know the horizontal component, and we need to know the vertical component. So we're going to use SOHCAHTOA to figure this out. We have a right triangle. We can use trig. So to find the horizontal component, that's the adjacent side, and the hypotenuse, we're going to do cosine. Cosine of 50 is equal to x over 8. And then we're going to times by 8 on both sides. And we'll get x is equal to, type that in your calculator, 5.14 is what that should come out to. And then we're going to do the similar thing for the vertical component. This time it's opposite in hypotenuse when we're looking at the vertical, so we're going to use sine. Sine of 50 equals y over 8 times 8 times 8. We're going to get y is equal to 6.13. We'll just round to 2 decimal places. So then to put it in component form, this is really easy from here. This is the I and j form is what we're looking for here. So this is going to be 5.14 I plus 6.13j. Or you could write it didn't really say which one. You could write it in this form too. Those are they're both technically correct ways of writing a vector. So as we look at more examples, you can kind of decide which form you like best, which one makes you combine like terms correctly. So go ahead and pause it and try the second one here. Try number 2 on your own, and then I'm going to walk through it in 3, 2, 1. So again, we want to start by drawing it first. This one does have a different degree, so it has 335 degrees, which means we're in a different quadrant. So that's going to be down here, 335 degrees. So then go ahead and form your triangle, always to the x-axis, and we're going to fill in that this is 335 degrees, and that the magnitude is 10. And then we're going to find the horizontal component and the vertical component. So the horizontal component, again, is adjacent hypotenuse. It's cosine. They are always going to be the same thing, which is why your book gives you a formula. But I don't like to memorize formulas. and you can actually put the 335 degrees in. Your calculator is going to calculate everything correctly here for you, so you're going to type that in. The nice thing is it will give you the right sign for your answer, so you should confirm it based on what quadrant you're in, but it's going to actually already calculate, since it knows we're in the fourth quadrant. It's going to give you a negative or a positive angle for cosine, but a negative angle for sine. So I typed that in my calculator and I got 9.06. And then I'm going to do the work to find y. That's going to be sine, because it's opposite and adjacent. Sine of 335 is equal to y over 10 times 10 on both sides. And I'm going to type that in my calculator. It'll give me the y component. Notice this comes out as negative 4.23. It comes out as a negative number, which makes sense because it moved down. So in component form, the answer would be 9.06i minus 4.23j, or you could write it in the bracket form, 9.06 comma negative 4.23. Either way, that's an answer. Okay? So you're going to have some homework to practice on these, and we'll talk about it first thing tomorrow when I see you guys again, and we'll kind of be pushing forward with little steps into more things about vectors tomorrow as well. The goal would be for Wednesday to be able to understand how to do word problems that talk about vectors and different forces acting on an object. All right, enjoy the rest of your snow day, and thanks for watching the video.